Hi, we're going to look at sections 3.1 through 3.3 in this video. First, we're going to start with introduction to bonding. Bonding is the joining of two atoms in a stable arrangement. And so atoms come together for multiple reasons and multiple ways to become more stable. If you're ever asking a question, well, why does this do this in chemistry? The answer is likely because it's more stable. So in bonding, elements can become more stable by gaining electrons, losing electrons, or sharing electrons to get to the electron configuration or essentially get the valence electrons of a noble gas. So we need to talk really much about electron configuration. So we can think about it as the valence electrons of a noble gas is good. So the valence electrons of a noble gas, remember, is 8 for most of them. And so we call this the octet rule, which we'll talk about a lot more later. Means that atoms like to get 8 valence electrons, because remember the valence electrons of noble gases is 8 electrons. And so there's a general rule that atoms are going to gain, lose, or share electrons so that they can get that 8 valence electrons on their outer electrons. If they're gaining or losing, so transferring electrons, this would be gaining or losing electrons. This is an ionic bond. If it's sharing of electrons, it's covalent. Ionic bonds are mostly between very different elements. If they are not going to share, they're going to be really different. So you've got things that have very, very high ionization energy, small size, and things with bigger size and lower ionization energy. So we get ionic bonds forming between different things, which are metals and nonmetals. So for example, you have sodium metal, which before it bonds is explosive in water. It's a shiny metal. You can see this person is kind of cutting sheets of it. We have chlorine gas, which is actually a toxic yellow gas. And then we put them together with ionic bonding and we get sodium chloride, which is table salt. And so we have these two kind of dangerous things. The chlorine gas is very toxic. Sodium metal will explode in water and then very unstable. And then once they bond and they get those 8 valence electrons, they become so stable that it's just table salt. That's just the transfer of a single electron makes that big of a difference. Covalent bonding, we're going to just touch on it here, and then we're not going to talk about it until chapter 4 again. But covalent bonding is when you have two nonmetals coming together, or sometimes you have a metalloid with a nonmetal. And we get a molecule that when we have this covalent bond happen, and then we're sharing electrons. And so there are shared electrons between two elements in a bond. So imagine that hydrogen has one valence, this hydrogen has one valence, and they go, hey, if we share both of these and we can pass these two electrons between each other, now we both look like helium because we both have access to two electrons. And so this is an exception to the octet rule, meaning everybody wants 8. Sometimes wanting 2 or getting 2 is fine, especially for hydrogen because it'll look like helium, which is also a noble gas. We're going to leave covalent bonding behind for now and focus on ionic. To focus on ionic bonding, we need to talk about ions. So we have two types of ions, cations and anions. Ions are just charged things. So in chemistry, we just say species. A species includes atoms, ions, elements, compounds, pretty much anything that we're talking about. We'll just say that the species. So ions are anything that has a charge. So any chemical thing that is overall has a charge. The number of protons and electrons in the charge are unequal. So remember from atomic structure, the charge can be calculated by looking at the number of protons minus the number of electrons. And if they're equal, if this is 10 and this is 10, the charge would be 0. So it's neutral if the protons and the electrons are equal. So neutral, protons equal electrons. If it's not neutral, if it has a charge, we call it an ion, and protons and electrons are unequal. So ionic compounds are just two ions that have a strong attraction for each other. So positive cations, these are positive ones, and anions are negative ions, and they attract each other because opposites attract. And so that's what makes ionic compounds. So how does this happen? So let's look at cations first. Cations are positively charged ions. I remember that cations are positively charged because cats have paws, and so positively charged for cats. Also, there's a T in cation, and T kind of looks like a plus sign, so you can remember however you want to remember that. So let's say we have sodium. So sodium has 11 protons, 12 neutrons, and 11 electrons. If sodium loses an electron, notice that if it loses an electron, see that 8 that it has on the next energy level below? So right now it's got 1 on the outside, but if it gets rid of this 1, the next level down is level 2, and if we count up the electrons in level 2 there, it would be 8. So it's that octet rule that's keeping this making this happen. So we go from having 1 in the outer shell, getting rid of that 1, and then now the outer shell is shell number 2, or energy level 2, and now we have 8. When we lose that electron, now we have 10 electrons. We call this the sodium ion. We would write it as Na plus, because we have a +1 charge. Our charge is protons, 11, minus electrons, 10, which would be +1. We don't say just 1, or we don't say just say 1 or 2 in charge. We always say +1 or -1. +2, -2. Here, your charge is 11 minus 11. So your charge is neutral or 0 for the sodium atom. So atoms are always neutral. Ions have a charge. It's not that all ions are positively charged, but in this case, this one is a +1 charge. So an ion can be positive or negative. When we're talking about anions, oh, here's another, sorry, this is another cation. So we can lose more than 1 electron. So magnesium has 2 electrons in that outer shell. If I get rid of those 2, I have that magic number of 8 here. So if I start with no charge, so we just say magnesium with no charge at the top right, and here we have magnesium that loses 2 electrons, so it becomes 2 plus. When you lose negativity, you become more positive. Lose negative stuff, become more positive. So plus in the charge sense doesn't mean add electrons. And we can't add protons because then we change the element's identity. So we're only dealing with adding and removing electrons. And we change the name. So we say magnesium atom when it's neutral, magnesium ion when it's charged. Anions are negatively charged ions. Anion has more electrons than protons, so it has more negative than positive stuff. So if we start with chlorine, chlorine, Cl, with a charge of 0 because it has 17 protons minus 17 electrons. If we see it has 7 electrons in the outer shell, well, it wants to have 8, and so it'll gain 1 to get to 8. For these, you can either they have, like this one has 2, it can gain 6 or it can lose 2. So it's easier to lose a smaller number than it is to gain a bigger number. Here we can either lose all 7 of these or we can gain 1, and gaining 1 is going to be a lot easier. So when we gain 1 electron, our charge now is 17 protons minus 18 electrons, and that's going to give us a -1 charge. So we say Cl minus, or Cl minus 1. Notice that we changed the name. We'll talk a little bit about naming later, but the chlorine atom, we say ion at the end, but we changed the ending of chlorine to chloride, and we did not do that for magnesium and for sodium. So with anions, we change the ending of the name when we are naming the ion version. So here's some other examples. And so everybody in group 1 has one valence electron. So they like to lose one electron, which means they'll become +1. So everybody in group 1 becomes +1. So the group number is the charge on the cation. So group 1, +1, group 2, +2, because they have two valence electrons, they're going to lose 2. And then group 3A, or we know it as group 13, is going to have a charge of +3. And so these are some examples, M standing for metals in those groups. Metals like to lose electrons. For your nonmetals, they're typically going to be your anions. And in group 5, which we call 15, 6A, which we call 16, and 7A, which we call 17, we look at these numbers. So we have 5 valence electrons. If we have 5 valence electrons, we can lose 5 or we can gain 3. Gaining 3 is easier, so we become a -3 charge. The charge is 8 minus the group number. So 8 minus 5 is 3. 6 minus 8 is 2. And 8 minus 7 is 1. So it kind of goes in let's see if they have, yeah, so they have a chart here. Group 1, charge of +1. Group 2, charge of +2. Group 3A or 13, charge of +3. Group 5A or 15, charge of -3, and then -2, then -1. So you can kind of see how it goes up and then it goes down. So +1, +2, +3, -3, -2, -1, and you can just look at the periodic table to guess kind of what your element is going to do. So here's that image again. So +1, +2, +3, and this is metals are positive. So metals only in that category. Then non-metals only in that category, -3, -2, -1. We don't include these here at the bottom because these are metals. And these are metalloids, and so they kind of do weird stuff sometimes. So notice that it's your metals in group 1s and 2 and 3 or 13, and your non-metals in group 15, 16, 17. And group 18, they don't make a charge because they already have that octet, that 8. Some metals have variable charge. So in the center of the periodic table here, we get a little mixed up. These elements can have multiple different types of charge. I want you to know a couple of them that they don't change their charge. I want you to know zinc is always +2. Silver is always +1. So know zinc is always +2 and silver is always +1. These are just, they come up pretty commonly on examples. Cadmium is also always +2. That's a little less common. Aluminum is in the main group, but it's always +3. And gallium is always also +3. So you can kind of see a pattern, +1s, +2, +3, +2, +1 in this little kind of backward stair step. If it's not group 1, group 2, group 3, top group 3, the bottom group 3s are weird, but top group 3s, group 2, zinc, silver, so pretty much aluminum, zinc, and silver here. If it's not one of these that I've highlighted right now, assume that it's got multiple charges. So you can say chromium has multiple charges. Manganese actually has multiple charges. Nickel can have multiple charges, but they don't go into the details of all of that in the textbook. So what you need to know is group 1 and group 2 are always +1, +2. And I want you to know aluminum, zinc, and silver for always being +3, +2, and +1. The rest, you can assume all other metals have variable charge, meaning they have multiple different charges that they can have. They don't always have the same charge. Some common ions you may find in the human body. Now, when we're talking about sodium, if you're talking about a patient having low sodium or something, it's not sodium metal. Remember, sodium metal explodes in water. It's sodium ions. When I say, oh, I need to drink milk because it's got calcium in it, it's calcium ions. Potassium, potassium ions. So a lot of the times when we're talking about things in the body, we're not talking about the element neutral. We're talking about the ions, including the iron in your blood is an ion. Magnesium, that's an ion that we're intaking. And so it's not just the neutral element. Ionic compounds are formed when you have that transfer of electrons, you get a cation and an anion. And so we're going to look at how that happens and then write some formulas out. We'll practice this a lot in class throughout the next several classes in the next week or so. So just kind of take your time with it. But basically, the rule is we want the sum of the charges in that compound to be 0 overall. So take a look. Sodium loses an electron. Where does it lose it to? Chlorine. Chlorine actually gained the electron. So we have an electron that transferred from chlorine. So we have, let me just draw your little, a little diagram here. So chlorine had 7 and sodium, see, I could do these in the right colors, then you wouldn't be confused. Chlorine had 7 and sodium had 1, and chlorine grabbed this one, and so now the chlorine has 8 and the sodium has 8, but it's the next layer down. So the sodium is +1, the chlorine is -1. We can see +1 and -1 cancel out to give you a formula, NaCl. So 1 sodium, 1 chlorine have 0 overall charge if that's what we put it in. Now, the ionic compound is not always just one atom of sodium, one atom of chlorine, for example. It makes this like crystal structure. And it's kind of a combination of like but for every 1 sodium there is a chlorine. It's a structure crystal lattice kind of thing that we got going on. So here is another example, calcium and fluoride. So calcium needs to get rid of 2 electrons, and so it becomes a +2 charge. Fluorine likes to gain 1 electron, so it becomes a -1 charge. Well, if calcium is going to try to get rid of 2 electrons, and fluorine can only take 1, we need 2 fluorines to take calcium's electrons. Because calcium is trying to get rid of 2, and fluorine will only take 1. So 2 fluorines come together for each 1 calcium, and what we get is a charge balance. The calcium becomes a +2, and each fluorine is a -1. So we get a formula where we show 2 fluorines and 1 calcium and 0 overall charge. So in this little crystal, we'd have 2 fluorines for every 1 calcium if you were to count those up. Here's some other examples. So for example, sodium and chlorine is a +1, -1. So it just takes 1 of each, and we write NaCl, 1 of each. Lithium is a +1 and oxygen is a -2. So we need 2 +1s to balance out a -2. So we would say 2 lithiums and 1 oxygen. So it took 2 lithiums, each with a +1, to add up to +2. It took 1 oxygen, because it's -2, to add up to -2. And so we don't need them, we need them to be the same. So one needs to be positive of the same number and the other needs to be negative of the same number. And you kind of have to just add up a number of the ions to make that happen. So that it takes 2 +1s to cancel out a -2. So we write Li2O, telling me there are 2 lithiums or 2 +1s. Here, if barium is +2 and iodine is -1, we need 2 -1s to cancel out a +2. So I say BaI2 in my formula. So total charge for iodine is -2 because there are 2 -1s. Total charge for barium is +2 because there's 1 +2. Don't try to overthink this. For this one is a little bit more difficult. If you see 3 and 2, you're going to have to get them to be the same. The least common multiple of 3 and 2 is 6. So if I have aluminum with +3 and oxygen with -2, it's going to take me 2 aluminums and 3 oxygens to make this equal, because the least common multiple of 3 and 2 is 6. Um, so I can go over this with you if you're a little confused about it in class, but there's multiple ways of thinking about this. I'll give you a shortcut in just a second. So we need 2 aluminums and 3 oxygens to make that work, so the formula would be Al2O3. So formulas tell you how many of each, and we put subscripts behind the number, behind the chemical symbol, to tell me how many of that previous element. So metals, remember, are your cations, nonmetals are your anions. For the first thing that you're going to do to write a formula is figure out who's the cation, who's the anion. So if I say write the formula for calcium and oxygen, we would write calcium and we write oxygen. We would write the charge of them. Now, how do we know the charges? We look at the periodic table. All metals in group 2 are +2. All nonmetals in group 6A, or we're learning this as 16, are -2. So we put O2 minus. If we're talking about chlorine, for example, all nonmetals in group 17 are 1 minus. And so write out the ions so you can see what your charges are, and then we can think about how to put them together. Now, if we want to put together calcium and oxygen, how many do you think we need if we have +2 and -2? Maybe you said that you just need one of each, right? If I have a +2, one +2 cancels one -2. So I get 0 charge when I put one of each. And we don't write ones for the subscripts in chemistry, so we just say CaO. However, if we have the chlorine, we would have to put together 2 chlorines to cancel a calcium, because chlorine needs is a -1 and calcium is a +2. So one way in which we could do that is the crisscross method that you may have seen before. So you put your ions like this. You're going to take the positive of one of them and move it, crisscross it to be the subscript of the second one. Then we take the negative number, not the charge, just the number, and then we crisscross it. So we get Ca1, Cl2. And again, we don't really use the 1, so we just write it as CaCl2. So think about it. I think that you're probably going to be most successful if you just think, how many -1s do I need to cancel out a +2? How many 1s do you need to make a 2? I need 2 1s to make a 2. So I write 2 of the thing that's 1, right? But if you just need a shortcut, crisscrossing is okay. If we go back really quick, I'll show you the downfall of crisscrossing. So if you try to crisscross this one, you're going to take the 2 and go here. We'll take this 2. Again, we only crisscross the numbers, not the signs. And we get Ca2O2. But you'd be marked incorrect for this, because in ionic compounds, we have to reduce to lowest whole number ratio. So you would have to take that Ca2O2 and make it CaO. So crisscrossing is fine, but if they have the same charge, just need one of each. So don't try to overthink it. I think that just being like, hey, how many 2s do I need to make a 2? You need 1 2 to make a 2. How many 1s do I need to make a 2? To match a 2. I need 2 1s to match a 2. So I need 2 Cls. Why don't you try, if we're done with this one, we'll have more to try in class. And there's a lot of practice that you'll have and homework and whatnot.